This is a demo for the final project, Fashion Item Classifier. So the project uses the dataset called Fashion Minist, which is a Minist-like dataset on clothing articles. So first, this part is to load the data from the CSV files. And from the description of the data, we can see that the CSV file has 785 columns. So the first column of the table is a label from these 10 classes, and the rest of each row is an image of 28 times 28 pixels. So for each row, we can plot an image like this. It is a fashion item in grayscale. So for further visualization, I use some of the dimensionality reduction method. The first one is PCA. So here I define 10 colors for these 10 different classes and plot the result of PCA. And when I try to reduce the components to 2, PCA is not giving a very good result. And when I change the dimension to 3, it does not change much. So I turn to another method called TSNE. And I try to reduce dimension to 2. And we can see that TSNE is successfully doing the dimensionality reduction. There's still some overlap among the classes. The overlaps happen mostly in the classes pullovers, coats, and shirts. So after visualization, I trained several different models. The first one is logistic regression. The logistic regression model I used is with penalty L1. And after training for 70 seconds, logistic regression gives a test score of 77%. And I also plot some of the classification vectors for these 10 classes. And we can see that logistic regression is trying to learn some of the features of these clothes, including the sleeves and the edge, especially the one between the trousers. And we can see that these features are not good enough to classify between these clothes, so the score is not very high. The second method I use is an MLP classifier. So firstly, in order to train this model in a short time, I only use very few hidden layers. And the training stops at the 26th iteration. The test score is 86%, which is a little better than the logistic regression. I also plot the weights of the MLP classifier at the first layer. So we can see the shape vaguely of a cloth, the sleeves, the top, and maybe the bottom edge. So after that, I increased the number of hidden units, and this time the training runs for almost 400 iterations. And now the accuracy is much better, not much better, a little better this time. The test score is now 88%. So at last, I used the CNN model with package Keras. This part I added the layers for the model, and the activation function I chose is ReLU, which is the most popular one for image classification. And however, the first training does not seem very successful. The test accuracy is only 54%, and given the performance of CNN, it should not be that low, as there must be some problem with this training. So I try to look into some correctly and incorrectly classified items. These are some of the examples that are correctly categorized, and some examples that are misclassified. And I don't see some clue from this visualization why the CNN is not working for this data. So I guess maybe I can try to normalize the data, which is to divide all the values by 255, and thus I turn all the values into a number between 0 and 1. And now I use the same model and the same layers, and I also train the data with 50 epochs. Unfortunately, this time CNN works and gives a high accuracy of 93%. And from the confusion matrix that we can tell that CNN is actually classifying most of the classes with a high accuracy, except for that for the shirts and coats and pullovers, it might be a little hard to classify. So I also plotted some of the images that are misclassified. So obviously the confusion is between shirts, pullovers, and tops. And record the TSNE visualization result. It is quite reasonable because these clothes do look similar to each other. So finally, I try to visualize some of the learning process in the CNN model. So this is a randomly chosen clothing item from the data set. And after the first layer of activation, it looks like it. So in order to get a general view of the layers, I plotted more images here. So after these three activation layers, and all these channels looks like this. And we can see that each channel is trying to learn some specific feature of this clothes, including the right edge of it, and maybe the long sleeves, and also some of the other edges. So from this visualization, we get a sense of how the learning behavior of CNN looks like.